Hello all. In this video, we will be learning about working MEMS microrobots. So this is one of the topic in the subject microrobotics of Unit 5, implementation of microrobots. So first, whenever we are learning this title, we have to know the empathy, why we are learning that, why it is important. So, what are the significance of this working MEMS micro robot? So, normal robot is visible, and usually every robot will have some controllers, sensors, motors for its locomotion. And the necessity of micro robot is when I want to do some kind of surveillance or when I want to do some kind of surgery or medical applications or biomedical applications, if I want to do that, then in that case, these types of micro robots are actually necessary. So that is the main empathy which we got for the title Walking MEMS Micro Robot. So for these micro robots, usually every component will be of small size. For example, the sensor should be a micro sensor. The controller should be a small in size microcontroller. Actuators should be micro conveyors and micro actuators have to be used. And fabrication has to be made for this micro robot. Micro-Electro-Mechanical Systems have to be used for implementing a micro robot. So, so these are the important things. Why we go for these types of small robots are like to increase the efficiency, to increase the scalability, to develop a swarm kind of robot. So these are the main necessities. If I want to send or examine a patient's blood vessel, in that case, a big robot is not possible. So because of that, we have to go with a micro robot. So these are the important things which are necessary, which makes us to develop a micro robot. So as I told already, micro electromechanical systems uh, is nothing but the individual component which is present in the micro robot. So to develop these types of systems, we have to come across certain types of uh, methods. The very first one is the photolithography, etching process, and the assembly integration. So, micro electromechanical system in the sense, in the system, I will be having both the electronic component as well as the mechanical component, and I will be fabricating them in a very small size. For small size, I have to go with certain methods like photolithography, etching, and assembly integration. So assembly integration is nothing but after developing all the components, I have to integrate them together by means of connections and communications. That is called as assembly integration. And etching process, before getting into the etching process is like we have to go with the photolithography. uh, Photolithography is a process where I need a substrate or a base part. In that substrate, I have to go with the photoresistive layer. So that photoresistive layer, I have to spread completely on the substrate. So that I can make a micro component. So the substrate is a base layer. On the substrate, I have to apply some photoresistive material and I'm applying it. I want it to be uniform throughout the substrate. So for that, I have to spin the material or the substrate. So I'm applying some kind of resistant and I'm spinning it so that it spreads evenly among the surface completely. So after that, I'm passing a photolithography. After that, I'm passing light on it, and I will be having, of course, I will be having a model or maybe a cartoon or any kind of fabrication or any kind of images. That image I will be having in a sheet. So that I have to place it and I have to do the fabrication process, which is again the heating process where the cartoon image will be printed on the substrate. And after that, I have to remove the dust materials. I have to increase the number of electrons, reduce the number of moles. So these are like P junction and N junction. We say it as doping, adding of impurities. And so that process we have to do. And if some unnecessary components are there in the substrate, in the product, okay, after photolithography, I can remove it by means of this etching process. So assembly, as I told already, it is like integrating all the small components like the sensors and the controllers, actuators, everything I have to bring them together in the form of a circuit so that it works out well. Yeah. So the next one is the mind map. For every title that we learn, we have to go with a mind map. So the mind map is, it actually leads to where it want to go and what is the pathway, why is it necessary to learn this title. So that is the main purpose of this mind map. And so here we have Walking MEMS Microrobot. So the main purpose of this one is like a walk robot. In spite of a wheeled or motored robot, here we are developing a walking kind of robot. Of course, for purpose we will be using micro batteries, power supplies we will be using. This is mainly used in microsurgeries and warm kind of robots we can use. So electrostatic hopping or electrostatic walking we can use uh, as the locomotion. And the structure of these robots, usually it will have some actuators, piezoelectric resistors, piezoelectric actuation. These are the structures, main components which we will be using while developing such a kind of walking MEMS micro robot. So here is a mind map, and here we have the control system, and every control system is like the brain of a human being for a robot. Here we will be having a small microcontroller system, and that will provide the signal. So So these are some of the challenges while we develop a micro robot. So they are like power density. It is costly. Efficiency will be more, accuracy will be more, but it is quite costly compared to developing a normal robot. So these are the reference websites which I have shared with you for learning purpose. I hope you would have learned from the video. See you in the next one. Until then, it's bye bye from Radhika.